In our next section, we're going to look at the SSL VPN feature on the ASA and look at the configuration of both the clientless SSL VPN or the web VPN feature and the SSL VPN client or the AnyConnect client. Now, the first of these variations, the clientless SSL VPN, which is also known as the web VPN, is essentially using the ASA as a proxy server where the end client using their web browser forms an SSL tunnel to the ASA. Then inside this tunnel, they can run other applications, whether it be web browsing or mail applications or Telnet or SSH. But from the client to the ASA, it's going to be encapsulated inside of TCP, typically over port 443 for SSL. Then on the ASA, it's going to come out on the other side, and the sessions are going to look like they were originated from the ASA. Now, the second variation, the SSL VPN client, or the AnyConnect client, is similar in the logic to EasyVPN, but instead of using IPsec as our transport with the ESP or AH protocols, we are using SSL, which again is going to be running over TCP port 443 by default. Now, the advantage of using the AnyConnect client over EasyVPN is that it gets away from any type of design issue where someone is filtering either the phase 1 or the phase 2 negotiation of IPsec, which could potentially be our ISA SA, which is established using UDP port 500, or the IPsec SA, which is established using ESP, AH, or some type of transparent tunneling, like our NAT traversal using UDP port 4500, or the transparent tunneling over UDP or TCP using port 10,000. So in very strict filtering networks, where possibly only port 80 for regular web browsing and port 443 for SSL are the only two protocols that are allowed outbound, then an SSL VPN connection would be the only option for an end client behind that type of filtering to be able to establish a secure tunnel. Now, configuration-wise, we'll see the logic of both of these variations, the clientless and the client-based SSL VPN, are similar in logic to the EasyVPN, where we're using the same tunnel group and group policy syntax, which means that we can use the show run all tunnel group and the show run all group policy to get some syntax help to figure out what are the default values and what are the different options that we need to issue in order to get the basic functional tunnel working. Additionally, we have another global configuration mode, which is the web VPN configuration mode, that is going to define some of the shared attributes between the tunnels. Things like what are the interfaces that we're listening for the connections on, what is the location on the flash of the SSL VPN client, which is also known as the SVC, and what is the port number that the ASA is going to be listening on, which is typically going to be port 443. We can see the defaults of this if we look at the show run all web VPN, and then also like the LAN-to-LAN and the other remote access VPNs for EasyVPN, we can look at the VPN setup output that's going to help us to build the syntax. Now, a couple other brief notes on the syntax for the SSL VPN. Since we're no longer using IPsec as the transport, we're no longer using the crypto command set. Where previously we would look at the show crypto ISA SA for our phase 1 verification, the show crypto IPsec SA for phase 2 verification, and then look at various debug crypto outputs in order to see any problems in the phase 1 or the phase 2 negotiation. But in the case of the SSL VPN, since we are no longer using IPsec, we're going to be changing syntax to the VPN-session DB, or the VPN session database. So to see what are the active sessions, instead of saying show crypto IPsec SA, we would say show VPN-session DB. If we wanted to see the debug output, this is going to be debug VPN-session DB. If we wanted to clear the connection, instead of saying clear crypto ISA SA or clear crypto IPsec SA, we would say VPN-session DB log off. Now, documentation-wise, you'll see that this is not as straightforward as some of the other configurations that we saw for the LAN-to-LAN VPN or for the remote access VPN, So you do want to be aware of where these are located in the documentation, but then also some of those shortcuts that we can do, like the VPN setup and the show run all, to help us piece this together on the command line. Where in a real design for the SSL VPN, typically you're going to be using the web GUI interface or the ASDM in order to piece a lot of these configurations together. In fact, if you search for SSL VPN in the ASA or SSL VPN in the iOS, you'll see the vast majority of examples they give you on Cisco's website are using either the SDM for the routers or using the ASDM for the ASAs. So within the scope of the CCIE Security Lab exam, you don't necessarily need to be an expert in customization of the website and all the possible options you can change for SSL VPN. You just want to make sure that you can get basic functional configurations for both variations. The clientless version, which is basically using the ASA as a proxy, and the SSL VPN client, which is the AnyConnect VPN, similar to the EasyVPN client. So documentation-wise, from the main page, we're going to go through the same structure where we start at products to security, firewall, appliance, ASA, configuration guides, then to our particular release 8.0 in this case. Then under configuring VPN, we have two separate sections here. The first one is for the clientless VPN, which again is basically the ASA as a proxy server. Then the AnyConnect VPN client, which is similar to the EasyVPN client, or what's sometimes called the Cisco Secure VPN client. Now, it would be a good idea just to read through these two basic documents to get an idea of what are the possible features that you could do with the SSL VPNs. So we can change things like what happens when a particular port is used from the client's perspective. We could configure that to forward to different internal ports on the inside. We can configure different types of email proxies, whether we're using Microsoft Outlook or other applications like Citrix or internet file sharing. These can be run over the proxy with the clientless VPN. But the big problem with this document is that it's not very clear what the entire final configuration should be for the clientless VPN. So I would recommend to use this as a reference. Make sure you know what are the basic overall features. But for the entire configuration, you're better off looking at the command line. And from global configuration here, the ASA will go through the VPN setup. This is going to be an SSL remote access VPN. If we look at the steps, we're going to see that the overall logic is similar to EasyVPN with some of the new syntax for the web VPN thrown in. Now, we know, of course, that first thing we would need to do is configure the basic interfaces, configure the basic routing. These steps would be required, but they're technically not directly related to the web VPN configuration. So out of this, we have our second step. It says turn web VPN on the interface, where this would be similar to saying crypto ISACamp enable outside, where by default the ASA is not listening for an IPsec tunnel. Same would be true for an SSL tunnel. We need to enable it on that particular interface. And this web VPN, this is that global configuration mode. Then we have the AAA configuration. If we were using the local database, we would then need to have a local username and password. And notice here that they are editing the default web VPN group, which would be similar to editing the default L to L group for LAN to LAN or the default RA group for our EasyVPN connections, where beyond just this authentication server that they're changing, which is saying use the local database, there's going to be a lot of other options that are defaults there that we can verify by looking at the show run all tunnel group. Then they're specifying what is the location of the SSL VPN client, which is the SVC. This is generally going to be some file that's on flash of the ASA. So if you look at the dir flash or the dir disk 0, dir disk 1, you should see some sort of .package file that's going to be used for the operating system, which in this case is Windows, to actually do the install of the client. Now with the SVC, that is talking about the AnyConnect client. For the clientless SSL VPN, we do not need to specify the SVC image, and we do not need to enable the SVC globally under the web VPN process. Then we see we have an address pool. This would be similar to allocating addresses to an EasyVPN client. Then we have the group policy, which would control things like the split tunneling policy. What's the particular banner that the users get? What is their WIN server? What is their DNS server? So just like the EasyVPN configuration, vast majority of these options you do not need to memorize. Just make sure you're familiar with looking at the show run all tunnel group, show run all group policy, and show run all web VPN. So next, let's take their example here and build it into a basic functional configuration. Where the first step is to simply turn the process on. So we have web VPN, and then this is going to be enabled on the outside interface. We're going to assume that the basic routing features are configured up to this point. We then have a tunnel group, which in this case they're using the default name, the default web VPN group. I'm going to change this so we are using a specific named group, which will make it a little bit more clear when we look at our final configuration. So I'll say that this is the, let's say this is the web VPN group. Where web VPN is a remote access type group, we're using the local database for authentication, which would then assume that we need a username and password entry configured. For simplicity here, I'll say username is Cisco, password is Cisco. In this example, they're specifying that the service type for the user is remote access. This would then prevent them from logging into the actual command line of the ASA, either through Telnet or SSH, or maybe even from the ASDM. So we could configure that technically. Technically, we do not have to. So we could configure that, but technically we don't have to. Next, we have the AnyConnect image, where we're going to save this one for later. This is going to be used for when we're doing the AnyConnect client. Same would be true of the SVC enable command. So that's going to turn the service on. Same would be true about the pool. Since we're not running the AnyConnect client yet, we don't need an address assignment. Then we have the group policy, which in this case they're using the default policy. And like the tunnel group, I'm going to change this so this is a named policy, where I'll say the group policy will be the, let's say, web VPN policy. And in the attributes, the tunnel protocols are going to be just web VPN. Yeah, we'll look at the context-sensitive help when we get to that. That's going to control, can we use IPsec? Can we use web VPN for the clientless access? Or can we also use the SSL VPN client, or the SVC? So this on its own is pretty close to our basic configuration. One other thing I will need to change is what is the group policy that is being referenced from the tunnel group. Because the way that they were configuring it, they were already using the default tunnel group and the default group policy. So those two are automatically bound together. Where in this case, I would need to say something like default group policy, and then what is the name of it? In this case, it's the web VPN policy. Now, whether this is the actual correct syntax or not, the ASA is going to tell us when we actually try to enter this on the command line. Now, from a design point of view in this topology, ASA2 is going to be the SSL VPN server. Whereas a proxy server, it is going to listen for connections coming in from the test PC. Then based on the individual application that we choose, it is then going to be redirecting traffic either back out to the public network or to the internal network. But in either case, it's going to be using the ASA as a proxy. So if we were to SSL clientless SSL VPN to the ASA, and then telnet to router 3, Router 3 is going to see the traffic as being originated from the outside IP address of the ASA. So just like any normal web proxy that you would use in any other configuration, where the idea is that we're configuring a tunnel between the client and the server, then from the server to the actual endpoint, it's a separate connection. So let's take this first portion of the configuration and then try to apply this onto the command line. So it looks like up to this point, this syntax looks pretty good. Now, before we actually test this, let's look at any of the other output from the defaults and see if there's anything else that we need to change. So let's say show run all web VPN. And we see the options that we could change in here would be like, what is the port number that we're listening for? By default, we have this enabled on the outside. Actually, no, we configure this. We enabled this on the outside. We could specify what's the size of the cache, whether the SSL VPN client is enabled. Another important one here is this next command, the tunnel-group-list enable. This is used when we have multiple tunnel groups. Then from the web interface of the ASA, the user can specify which tunnel group do they want to authenticate to. Where we could say I have one group that's for sales, one group that's for tech support. Then they choose the group from a drop-down list and then authenticate to that particular one. Where in the case of our EasyVPN tunnel, the group was chosen based on the pre-shared keys or based on the certificate of the user. Next, let's look at the show run all group policy, where the default group policy says for the web VPN, there's no type of filtering as to what destinations they can or cannot reach. We could do port forwarding. We could see some of this stuff is going to be customization of the web interface itself. It says what's the MTU size of the SSL VPN client. If we're doing some sort of additional tunneling, maybe we want to reduce the MTU even smaller. Or if we do not need that small of a payload, we could increase the MTU. But you can see most of this, you wouldn't really need to customize unless you had a very specific reason in order to do it. We can also see that the default group policy is going to control other options like what are the VPN tunnel protocols we can use, where we can use IPsec, Layer 2 tunneling protocol, and WebVPN by default, but we could not use the SSL VPN client. We would need to say VPN-tunnel-protocol SVC. Then additionally, this is where we would define the split tunneling policy. So when we're using the AnyConnect client, just like the EasyVPN client, this is where we would specify what traffic goes over the tunnel and which traffic does not go over the tunnel. Then lastly, we have the show run all tunnel-group. Where in the tunnel group here, we want to look at what is the default web VPN group. So the web VPN group says that there's no address pool configured. We're checking the local database. We're using the default group policy. If we were to use certificates for authentication, we would get the username from the common name and the organizational unit. Then the rest of this is going to be specific to the web VPN. So now let's check the result of this. Let's go to the Windows machine, the test PC, and we're going to open an SSL web browsing session to the outside interface of the ASA. And ideally, what we should see is that on this address, the ASA pops up a login box that we can then use to connect to it as a proxy server. So on our web browser, we're going to go to https 200.0.122.12. We can see now we get the request to accept their certificate. In this case, if we look at the view certificate, this is self-signed by the ASA itself. If we look at the details, typically in a real design for this, you would have a public certificate. So maybe something that's signed by VeriSign, for example, so that when the users browse to that interface, they're not constantly going to be asked to proceed. Or like if you were to open this in Firefox or Chrome, sometimes it'll give you that big warning message saying that you should not continue with the connection. Basically, this is just because it's a self-signed certificate, not one that's coming from a trusted certificate authority. But eventually, once the web page loads, we should get to the portion where we have our username and password. Or in this case, our username is Cisco, password is Cisco. From here, we get to the web portal, or basically the proxy server page, which on the left, we can choose what's the particular application that we want to use, and then either manually enter an address into the URL bar, or if we have pre-configured it on the ASA, we can have a list of links that is going to go to common services that these users would be using. So for example, if we were to click on Telnet SSH, it changes what is the particular protocol that we want to use. If we were to look at Telnet, for example, we could manually type an address in here. Let's say router 3's address of 200.0.0.3. Or we could have the list of the common servers that these users are typically using. Now, if we connect the session here by saying I want to browse to that address, so 200.0.0.3, if we look at the diagram, 200.0.0.3 is the loopback address of router 3, where normally the test species traffic would be going to ASA 1 to router 1, from router 1 to router 2, from 2 to 3. But in this case, since we are going over the SSL tunnel that is going to ASA 2, the traffic is going to go this direction over SSL. Then from ASA 2, it's going to go back to router 3 over a clear text connection. However, when router 3 receives this session, the source address is going to be the outside interface of the ASA. So it's only encrypting the traffic that is going from the client to the server. It's not from the client to the SSL server, I should say, which is ASA 2. It's not going to encrypt the traffic from the ASA to router 3. See, now it asks us for, do we want to run this Java application? This is where the actual telnet is going to happen, inside of this, this web-based Java app. So now we can see the final result is that we have the telnet session open. If I log in here with the username Cisco, password Cisco, which is pre-configured, on router 3, we're logged into the exec process. If we look at the show users, though, it says now the session is coming from the address 200.0.122.12, which is the outside interface of the ASA, not the actual address that is assigned on the end client. If we look at the IP config of the Windows machine, this is currently assigned to the 192.168 address, but we're using this address 200.0.122.12 basically as our proxy. So the final result of this, when we look at the syntax, there's really not that much configuration that we need to do in order to get the basic web VPN tunnel working. The vast majority of the additional configuration is if we want to run the SSL VPN client, or the SVC, in order to treat the SSL tunnel the same as a remote access easy VPN connection. Now, when you're testing this out, there's a couple different caveats for testing this on the equipment. One of them is going to be that when the client connects, in this case the test PC connects to the ASA, the VPN client software is going to be downloaded from a Java interface. First problem is that generally just the Java interface itself is very slow, so it may take a large amount of time in order for this to load. But also in a topology like this, where the traffic has to transit this frame relay segment between router 1 and router 2, these links are physically 64 kilobits per second. So it's going to be really, really slow downloading the client over that. So for this particular example, what I'm going to do is move the test PC from this segment onto the segment right in front of the ASA. So we'll put it in the 200.0.122 network. We'll say that this is the .100, and we'll use router 2 as the default gateway. Now, the end result is going to be exactly the same as if we were to leave it on that VLAN 118 network. It's just going to take probably 5% of the time, if not even less than that, in order to load the VPN client that we're getting from the ASA. So this means a couple basic changes. One is that on the end host, I need to change its address. So I'm going to go to the control panel, network connections, and then change the inside of the lab adapter. Now, if you are using our equipment for these labs, feel free to play around with this. You can set these to whatever you want. Obviously, though, just don't change the one that says do not change, because this is the interface that's used for the actual remote desktop connection in order to get to the web interface of the Windows machine, or not the web interface, the GUI interface of the Windows machine to begin with. But you can change these addresses here. You can change the default gateway, the DNS. It's not going to hurt the configuration. So here I'm going to change this to 200.0.122.100/24. The gateway I'll set as router 2. And a DNS, I'll leave this blank. We don't need a DNS server. Then this also implies that I need to change the connection that is the physical layer 1 and layer 2 circuit going to the test PC. And this is on switch 2's port fast Ethernet 20 in our topology. So on this link, I'm going to change this to be in switch port access VLAN 122. Where now if I were to go to router 2 and ping 200.0.122.100, this is now the new address of the test PC. Now, if I were to go back to the test PC and do the same browsing that we did before, where I go to https://200.0.122.12, you'll generally see that this is going to load a lot faster, because the problem is not only the Java load time, but it's also the bandwidth that is in the transit path from the client to the server. Now, for our next example, using the SSL VPN client, we do need to add a couple of additional configurations that they did show in the previous output of the VPN setup, where I need to specify where is the actual SSL VPN client image located. And the reason I need to specify this is that the Windows machine is actually going to be downloading and installing this from the ASA itself. Where normally in an EasyVPN configuration, you would have to have some sort of offline mechanism to actually distribute the installer for the Cisco Secure client. Now, if we go to the ASA and look at Now, if we go to the ASA and look at the DIR output, it says that on disk 0, we have this image that is the AnyConnect client for Windows. So next, under the web VPN configuration in global config, we need to specify what is the SVC image location. So this is going to be on disk 0, and the file name is AnyConnect. This version is 2.3. I would then need to enable the SVC. SVC access is off by default. SVC enable. The SVC profile would then be basically like an XML file that is going to control some of the attributes of what the client is allowed to do once they actually connect. And we'll look at an example here of modifying what the default profile is for the SSL VPN client connection. Okay, so now we have the ASA actually listening for the SVC connections. I would also need to specify what are the particular tunnel groups and group policies that are going to be associated with the SSL VPN client connections. Now, as I mentioned before in the previous IPsec tunnel examples we did, the tunnel group is controlled based on how the user authenticates or based on the username that's located inside of their certificate. But in the case of the SSL VPN client, we don't have an IKE identity that is going to be exchanged during the SSL negotiation. So when we define these tunnel groups, we are going to essentially configure a drop-down list that's going to be located on the main web page of the ASA, once we browse to it, that we're going to control which particular tunnel group are we going to authenticate to. So I'll say that this tunnel group is named, we'll say this is the SVC group for the SSL VPN client. And the SVC group is of type remote access. The SVC group, I then need to specify what are the general attributes and what are the web VPN attributes. Now, the web VPN attributes, this is where we would specify what is the name of the drop-down list that the users are going to choose. This is what the group alias is. There's a lot of other options that you can change here, but really the only one that I need to specify is what's the group alias. The only reason that I really need to do this, though, is that I have multiple tunnel groups. I have one tunnel group that I want to use just for web VPN access, which is the clientless SSL VPN. Then I have this separate group that I want to use just for the SSL VPN client. So I want the user to be able to choose which one are they going to use. So I'm going to specify the group alias. We give it a name now. Let's say that this is the SVC users. And I want to enable this. Okay, so now I have the tunnel group configured, and I have the alias that they're going to see when they try to log in. The next thing I need to do is to say, what is the individual policy that these SVC group users are going to get when they log in? And that's going to be controlled by the group policy. So now I need a new group policy. We'll say group policy. I'll say that this is the SVC policy. This is internal, so it's not from a AAA server. And I need to mainly specify here what is the And you can see there's a lot of different options we can have under here. So I need to specify that for this group policy, what are the attributes? And specifically, the attribute that I want is what's the VPN tunnel protocol? Where by default, this does not include the SVC, which is what I want, the SSL VPN client. From here, I would have the normal group policy attributes, like what's the split tunneling ACL, what's the address pool that I'm going to get my allocation from. Then if I'm also doing a per profile, or the SSL VPN client profile, this is where I would specify this under the web VPN parameters. So you can see that there's the group policy, and then inside the group policy, there's a web VPN sub-configuration mode. So we can configure a lot of the customizations from under here. But at a minimum, really the only other ones that I need to specify are where are we going to get the addresses from? So is it going from an external DHCP server or is it local? And what is the access list? Now, I technically don't even need to specify the access list. What that is going to control, though, is when this PC connects. So it's actually just one hop here. When it connects in the tunnel, am I going to send all the traffic out the tunnel, or is it only going to go to certain destinations? So if I wanted this to behave just like our previous EasyVPN tunnels, I could say send the traffic only to the 10 network out the VPN tunnel. Because I'm coming in the back end here from my remote desktop, and I want to make sure that I'm still allowing this traffic to go through. So I'll now configure an access list. We'll say that this is the access list is the SVC ACL that permits traffic coming from the 10 network going anywhere. So just like an EasyVPN, this is from the perspective of the ASA. I would then need a pool, an address pool, or an external DHCP server. In this case, I'll say IP local pool. The name of it, we'll say that this is the SVC pool. And what are the addresses that we're going to give them? Let's say 192.168.1.1, and we'll go through 192.168.1.254. What's the net mask? We'll say the mask is then /24, so 255.255.255.0. These two options, though, just like in the IPsec configurations, the local pool is not automatically bound to the policy, nor is the access list. If we look at the show run all group policy, this needs to be specified as what the address pool is and what the split tunneling policy is. So I would say tunnel specified, and then tunnel for that network list, which is going to be the SVC ACL. So now if we go back under our group dash policy, SVC policy was the name. And under the attributes, I need to specify what is the address pool, where the value of the address pool was what I previously defined up here, the SVC pool. Then for the split tunneling policy, I want to tunnel specified. And the split tunnel network list, which is the ACL, has a value of the SVC ACL, is what I called it. So now let's look at the rest of our configuration. Let's look at the show run tunnel group, the show run group policy, and the show run web VPN. So under the web VPN configuration mode, there's really not that much that we need to specify here. We just need to enable it on the interface, say where's the file located, and then enable the SSL VPN client, because this is off by default. Then we have the group policy, here the SVC policy, which is allowing them to run that tunneling protocol, which again is disabled by default. I have the split tunneling access list, which I don't technically need. The address pool I do need because I need to give them some sort of allocation. Then under the web VPN policy, or excuse me, the tunnel group for SVC group, really the one that is key here is what is the alias. Now additionally, I'm going to go under the tunnel group for the web VPN. And under here, I'm going to have the web VPN attributes, and likewise specify what's the group alias. I'll say these are the web VPN users. So what we should now see is that when we go to the Windows machine and start a new connection to the web interface, it should ideally give us two separate options. It should be giving us the drop-down that says, do I want to be in the SVC users, or do I want to be in the web VPN users? Where most likely what's missing here is that I didn't enable it globally under the web VPN process. So let's look back here on the ASA. Let's say show run web VPN and show run all web VPN. And this is going to be the tunnel-group-list enabled. So this is off by default. I then need to say under web VPN, put that drop-down list there, which is the tunnel group list. If I were then to refresh this page, we now see the drop-down. So do we want to be the SVC users, or do we want to be the web VPN users? Now for the web VPN users, nothing should have changed versus what we had before. So if I log in here, it's going to give me that interface where I can then control what services am I going to use. Am I going to do normal web browsing? Am I going to do telnet? Am I going to do file sharing, email? But the key is that I'm going to be using the ASA basically as the proxy server. So again, if we were to go to telnet, and let's say we were to telnet to router 1, we'll say 200.0.0.1. When the Java applet loads, we'll log in as Cisco, password Cisco, look at the show users. It says this connection is coming from 200.0.122.12. But then if we were to look at the IP config of the Windows host, their address is actually the 122.100. So our connection is now being proxied through the ASA, where again, this is the clientless SSL VPN. Now, if we start a new session, but in this case, we're going to authenticate to the new group, which is the SVC group. So we're the SVC users. Same login and password because this is globally under the ASA. The difference is now we should get to this page where the Java applet starts to install the SSL VPN client. Now, in this case, it sent me to the normal clientless SSL VPN page. What this most likely means is that the tunnel group that I configured either doesn't have the correct group policy assigned, because the group policy is determining what's the tunneling protocol. Is it web VPN or is it SVC? Or I am calling the correct policy, but the policy doesn't have the correct protocol defined as well. So let's, on the ASA, let's look at the show run group policy, where the policy SVC policy says we're going to use that as the tunneling protocol. Then this group policy, this needs to be called from the tunnel group. If we show run tunnel group, the SVC group has not specified a new default group policy. So it's inheriting the global configuration, which is to use the web VPN or the SSL clientless SSL VPN. So now for this particular tunnel group under the general attributes, like you can see for the one above that. Under the general attributes, I need to say that the default group policy is the SVC policy. That's the one that I defined. So now if I were to disconnect and reconnect, log in as Cisco and Cisco under SVC users, we're now redirected to the page where we're going to start to install the client. Now, if we were to look at the ASA, at this point, this is where we could look at the debug VPN-session database. And if we were to turn logging on, logging to the console at level 7, and logging is on, this is going to show us the actual negotiation of the tunnel. So one thing it's asking me to do is to run the ActiveX control. So let's install that. Then you could see the details of the SSL connection. It says that it is using TLS version 1. It's going to port 443. My identity is 200.0.122.12. Connection is coming from 200.0.122.100. From the client side, it's going to ask us to do this installation, where now it's going through the download process. And you can see even though they're connected on the same segment, it's still not very fast. It's only downloading at 10 to 20 kilobits per second. So if we had to go over that 64K link, it's definitely going to be much, much slower in order to do the installation. This problem here, this is actually a combination of the Windows machine being very low powered because the VMware virtual machine doesn't have many resources allocated to it. And then the ASA 5510, this is basically the lowest level platform that you would run this on. So it's going to be pretty slow compared to some of the higher level platforms. So eventually, once the client fully installs, then we should get to this portion where it's going to ask us what the username and password is. But notice we now have an error message that says the VPN establishment capability from remote desktop is disabled, and a VPN connection will not be established. So essentially, the client knows that I'm connecting to the Windows machine through remote desktop as opposed to locally on the console. So it's going to disallow this connection. Now, in a real environment, if you were local on your machine, you're not going to have this problem, like on your desktop or your laptop. If this was a virtual machine that you were connecting to through the VMware console, or even if you were using a VNC connection, the VPN client is not going to know that. So it's only basically that I'm doing the remote desktop in order to connect to the machine that it's stopping me from doing this. So now I have a couple different options. I could actually connect to the VMware client through the VMware console. I could use VNC for the connection. But instead what I'm going to do is show how to change the SVC profile, which essentially is the AnyConnect profile template that controls what are the individual access options of the client and whether they can do, for example, this. It says remote desktop. Is it allowed or is it disallowed? Now, this is kind of a more obscure configuration where within the scope of the CCIE lab exam, I highly, highly doubt they would have you do this. But from a real production implementation point of view, it is useful to know exactly where this template is located and what you can do in order to make changes to it. So once the SVC is installed, you'll see there's a program group here for Cisco and then the AnyConnect client. So it's basically going to behave the same now as the regular Cisco Secure client. The only difference is the transport, that we're running over SSL, not running over IPsec. But if we go to the search function of Windows and the specific file name, so let's say all files, and it's probably a hidden file. Let's say search for hidden files and folders. The name is AnyConnect AnyConnect profile.tmpl for template. And of course, you could search for a wildcard version of this where it says the location is my specific user profile. So it's under application data, Cisco AnyConnect VPN profile. If I were to open this in Notepad, basically what this is just an XML file that's going to control what are the different options that the user is allowed to do once the connection starts. So it says certificate store override is false, where this setting allows an administrator to direct AnyConnect to search for certificates in the Windows machine certificate store. This is useful in cases where certificates are located in the store and users do not have administrative privileges to their machine. So you can see a lot of these are very, very specific. And you can spend some time reading through this to figure out exactly what you would or would not need to change. But what I am looking for specifically here is there's an option that says Windows VPN establishment. This one, Windows VPN establishment. It says this section enables the definition of, no, it's this one before. The section setting allows the administrator to control if a VPN connection may be initiated by a remote user, which is what I am currently. I would need to change this local users only. I would need to change this to say allow remote users. And I'm not 100% sure if this is case sensitive. So you could try it either way to see if that is or is not case sensitive. So now I'm going to save this on the, I'll save this on the desktop, and I'll say that this is, let's say, my profile. Now this profile was dynamically downloaded from the ASA once the connection established. So essentially what I need to do is now get this particular profile to load on the ASA's flash. Then I can use this to offer it to other clients. And that's what the SVC profile value is under the group policy. Or I could even technically configure this under an individual user, specify different profiles for individual users. So in order to do this, I need to somehow get the file there. So I'm going to use TFTP, where I have a TFTP server running now on the desktop. Then on the ASA, I'm going to say I want to copy from TFTP. The address is 200.0.122.100, and the file is my profile.tmpl for template, and I'm going to copy this to disk 0. It says file is not found. So let's see, what is the extension of this? It changed it to .txt. So I don't believe it actually matters what the extension is. Let's try. Actually, let me resave it just in case it does matter. Let's say myprofile.tmpl. Okay, so now it's that template. So let's try it again from the ASA. Copy TFTP myprofile.tmpl to disk 0. Okay, if we look at the dir output, now I have that template. If we were to actually view it, if we were to say more disk 0 : my profile, inside here, eventually we should get to that point where it says the allow remote users under the VPN establishment, which is this one, allow remote users. Okay, next thing I would need to do is assign this either to the user or to the group policy. And if we look at the show run all group dash policy, this is the option under web VPN that is the SVC profile. So I'm going to say that for this particular policy, where my policy's name is SVC policy, so group-policy, group policy, SVC policy attributes, under web VPN, the SVC profile has a value of, actually I need to specify it globally first. I need to say, and let's turn logging off. Let's say no logging console. I need to specify under the web VPN mode globally, what is the SVC profile. We'll say my profile is actually the file disk0:/myprofile.tmpl. So now under that group policy, SVC policy attributes, under web VPN, the SVC profile value is my profile. So again, stuff like this, you can see it's very, very specific. It's unlikely that you're going to find this in the documentation. You probably would find it in like a tech tip or a configuration example. So you don't really need to get into this level of detail with the SSL configuration. The reason I'm showing this, though, is you can't demo the actual tunnel unless you have local access to the console of Windows or you're allowing this particular option. So let's try this again now. Let's run the VPN client. So we'll browse to that address. Login as Cisco. This should trigger the AnyConnect client to start. If we look down here in the status bar, just like you have with the regular client, if we double click on it, we get to the statistics. It says now my client's address is 192.168.1.1. If we were to go to the Windows command line and look at the IP config, just like we have for the EasyVPN client adapter, we now have the AnyConnect adapter, and we have the address assigned. If we look at the route print output, we should have the split tunnel ACL installed via the tunnel interface, where I have 10.0.0.0/8 is via 192.168.1.1. If we now try to actually send traffic out the tunnel, so if we look at the topology here, this would be from the test PC's perspective. Let's say that we were to telnet to router 6. If we telnet to 10.0.6.6, from the show users output, I'm coming from my tunnel interface, 192.168.1.1. If we now look at the ASA in the transit path, ASA 1 here, and look at its connections, on ASA 1, if we say show connection detail, or show connections all, what we will see, and right now no traffic is being sent, but let's go to the PC, and or actually no, I forgot, it's not on that segment anymore. It's now on this segment here. So the SSL connection is directly one hop away. But if we look at ASA2 and the show VPN-session database, we see it says that for the SSL VPN, there's active tunnels. Okay, there's one active SSL tunnel. If we say debug VPN session VPN-session database, then we were to send traffic over the tunnel. So let's say I ping router 6's address, for example. If logging were on, so logging console 7, let's disconnect the tunnel and then reestablish it. So we can see now the ASA shows the individual negotiation where we're assigning the address 192.168.1.1. We would also see the encryption that they are negotiating. In this case, it says RC4 SHA is used for the SSL connection. And this is going to depend on the individual client. So the version of the client that the ASA is then downloading to the, or I should say uploading, the ASA is uploading it to the client. That's going to control what the particular encryption and the authentication that it's using is. If I then wanted to disconnect the session to clear it and reestablish it for any type of troubleshooting, I would say VPN-session database log off. Then I could choose the individual session. I'll just say all of them. Then we should see from the Windows machine now the connection is going to be closed. But when we compare the final configuration of this to the other EasyVPN tunnels, it's not that far of a stretch. The problem is that there's just so many minor customizations that you can do with the SSL VPN client and the clientless connection. It quickly starts to get overwhelming what the end result of the configuration looks like. But here we have our global web VPN options, which is turning it on. Where is the file for the actual client software? We're turning the SVC on, and then saying that we're giving them that list of the dropdowns. What is the particular group? For the clientless tunnel, we have a group policy says that they're using the web VPN protocol and that they're using a different group policy. Or no, this is the group policy. Then the tunnel is down here further. Web VPN group says they're using that policy. But notice here, this is basically the only thing that we're defining under the tunnel. When we configured multiple tunnels, then we had to add the group alias to make sure they can choose between the dropdown. Now, if I didn't want this particular group in the dropdown, I could remove this. Then for the SVC, we have the same configuration here for the tunnel group. Under the group policy, we have our more IPsec-like options, like the split tunneling access list, the address pool. We need to specify that they can use the SVC. And then in the case of the custom profile, that was to change the basically XML attributes that are downloaded to that individual client.